Hello, in this video I'm going to talk about properties of inverse function. Alright, as you see that there are properties where I'm going to show you that what types of properties that fxn is inverse. Alright, so of course at first here you must know that this function is defined for x between -1 and 5, which is included the -1, right? So the first thing that you must know that inverse function only exists, inverse function exists, alright, exists if the function itself is a one-to-one function, right? One-to-one functions and onto, alright? So it's a, if fx is a one-to-one function. So, and you also know that the domain, okay, let's say you have, okay, I have to tell you that if this is the object and this is your image, right, and this is your image, this is your image, so under the mapping of f, which is onto, means that every image here have an object here. So now, and you going back, this will be your f inverse, and this is your f, right? So I can say that this will be your domain, right? The domain, the object, the domain of f, and this will be the range of f, right? Range of f. So as when you're mapping from here back to the inverse, right? So this will become the object, right? So the object here will be referred to the domain of the f inverse, and this will be the range for the f inverse. So from this diagram clearly said that the domain of f must be the same as the range of f inverse, and at the same time the range of f will be the domain of f inverse. So then this is the first one, is it must be a one-to-one function. Second, this will be the properties. So okay, let's look at this curve here. I'm going to explain about the properties by using graphical and algebraic. So if you see the fx is x minus 2, so you want to find the inverse here, right? You're going to let the y equals to inverse of x, and this method here you to find fy equals to x, right? So now you're going to substitute the y into the function, so and the y as your subject, right? As your subject, so that you can find the f inverse. So y will be x plus 2. So as you know that the y will be f inverse of x, which is x plus 2, right? Alright, so how to define the domain for f inverse, right? Range for f inverse without sketching the graph, alright? Without sketching the graph. So sometimes you have no need to sketch a graph in order to find the domain and range, right? So, and by looking at the domain and range for f, you can know the domain of f inverse and range of f inverse without sketching the graph of inverse function. So let's look at this, right? Let's look at this. I'm going to draw this graph nicely. So x0 here, right? The 0, so you have -1, 1, 2, 3, 4, 5, right? This is the range. So here you have 1. You must make sure that your scale is 1-to-1. But when you want to show the relationship between fx and f inverse, or you want to show the properties of the inverse and the function, is very encouraged. You must make it become 1-1, right? 1 cm to 1, 1 cm to 1 here. So 1, 2, 3, 4, 5. Okay, they have -1, -2. Okay, just draw some. So, and you sketch the graph of x minus 2. But remember, there is a restricted domain here, right? For these cases, it's a restricted domain. It means they only want the -1 up to 5, right? So you substitute the -1 into the, you can build a table here, right? For the xy, for the straight line graph, you just need 2 points, right? You're taking the -1 and the 5. even though not included 5, but doesn't matter, you can use these 2 points to draw the line. So when x is negative 1, your y will be negative 3. When x is 5, right? When x is 5, when the x is 5 minus 2, you will get 3, right? You are getting 3. So it means that you're going to put this point, negative 1, negative 3, negative 1, negative 3. It will be here, right? I will make it a solid circle because there is an equal sign here, right? And 5. So during 5, it will be 3. During 5, it will be 3. Right? It will be 3. So if you want to go for further, you can find for the x-intercept or the y-intercept here. So the y-intercept in this case will be, if you want to go detail, you can find the straight line here. So you will look at this one, negative 2. Negative 2 will be your y-intercept, right? Y-intercept. And how about the x-intercept? X-intercept, y equals to x minus 2, right? For this graph here. So x-intercept, y equals to 0, right? So x minus 2 equals to 0 and x equals to 2. Means they were cutting at 2 also, right? So if you if you draw the line, this will be the line for the graph of fx equals to x minus 2, just for this region, right? It's supposed to be everything, right? But we are controlled by negative 1 up to 5, right? So from this graph, we can find the domain of f. The domain of f is already given, right? The domain of f. So which is from negative 1, include negative 1, the x value here, there are no graph here, right? Negative 1 up to 5. But the 5 have to be open. Because why? It's not included the value 5 here. So, and the range here, range we see, there is no graph for y value until negative 3, right? Start from negative 3, included negative 3, up to maximum 3, but not include 3. Not include 3. So this will be the domain and range for this function, right? For this function. So without sketching the graph for f inverse, by the properties of inverse function, the domain of f will be the range of f inverse, and the range of f is the domain of f inverse here. So it means that if you want to find the domain of f inverse, it will be the range of f. Very easy. They will just interchange. The domain will be the range. The domain here will be the range for the f inverse. So it means that the domain of f inverse will be negative 3 up to 3 without sketching the graph. So the range for f inverse without sketching the graph for f inverse is what I mean. Alright. So this one you may sketch the graph. So the range for f inverse here will be the domain of f from negative 1 up to 5 here. So by follow these properties, right? So now again, I want to teach you how to sketch the graph of f inverse on the same graph here. So to see the properties. So as you see that if you're sketching this graph, you will know that they were reflected about this line here, right? If you're sketching, for example, if you sketch this graph, it will be exactly the same here. So the domain will be the range for this, and the domain for this will be the range for this. So if you see that, you need to sketch the graph, you need to sketch the line y equals to x. You have to sketch the line y equals to x. So if you sketch carefully, negative 3, there will be a line y equals to x here. You sketch the line y equals to x. Later you will see that this line will be reflected about the line y equals to x. For example, I will show you how to do it. This point will be negative 1, negative 3, right? Negative 1, negative 3. So when you reflected about at this line, for this line, if you reflected, it will be negative 1, negative 3 will become negative 3, negative 1. The order pair will change. So it means the negative 3 here and the negative 1, there is a point here, right? It's reflected here. So for this one, the negative 2, there will be a negative 2 over here, right? And if there is a 2 here, there will be a 2 here. They were reflected. And for this point, this will be 5, 5, 3, right? 5, 3, 5, 3. So when you reflected about the line y equals to x, the 5, 3 will turn into 3, 5. All right? 3, 5. So 1, 2, 3, 3, 5. So if you sketch the graph, sketch the graph, then you can see that this is the graph for inverse of f, and this is a graph for fx, right? So they were always symmetry about the line y equals to x. So you can actually sketching this in a separate diagram and it transfer to here. They were also exactly symmetrical about the line y equals to x, right? So this is the properties by using graph. So another thing here will be the inverse, the composite function of the f and inverse function is always you see that the composite of f and f inverse. Okay, let's try. You will find out something. F inverse of x here, right? So f inverse will be x plus 2, right? X plus 2. If you find the composite of f and its inverse, you are getting an unknown. Okay, x plus 2. The x plus 2 you have to put inside here, right? The f inverse, the x plus 2, x plus 2 minus 2. You are getting an x here. Can you see that? You are getting an x. So it's same thing also if you find for f inverse f, right? You see, I changed the order. So will be the f inverse of the fx. The fx will be x minus 2. And you put it into the f inverse. You put this into the x minus 2, x minus 2 plus 2. Plus 2. You are still getting an x. This is to verify that these two is the inverse of each other. Alright? So this is the properties here. So it have to be a one-to-one function. And secondly, the domain of f has to be the range of f inverse, and the range of f have to be the domain of f inverse. And by graphically, if you draw both of the graph, they will be reflected about the line y equals to x here. So you see that the domain of f inverse is -3 up to -3 up to 3, right? -3 up to 3. And the range for f inverse will be -1 up to 5, right? So this is the properties of inverse function.